This is the Secondary 2 Honors Module number 8, the first video. There will be 2 videos. And in this one, we are going to be learning about long division of polynomials. So let's review long division, like you learned back in elementary school. The way that works is if you're saying 9,849 and you're dividing it by 7, then you remember you say, well, 7 goes into 9 one time. And so 1 times 7 is 7, and then you subtract that. 9 minus 7 is 2. And you're going to bring down the 8. And so you're going to say 7 goes into 28 4 times. And 4 times 7 is 28, and then you subtract that. You get 0, and then you bring down the 4. And then you are going to say 7 goes into 4 0 times. 0 times 7 is 0. Subtract it, bring down the 4, bring down the 9, and so then you have 49, and say 7 goes into 49 7 times. 7 times 7 is 49, subtract it, you get a remainder of 0. That means that 9,849 divided by 7 is exactly equal to 1,407. It also means that 7 times 1,407 is equal to 9,849. So 7 and 1,407 are both factors of 9,849. Let's do one more to review. So 8 goes into 216. You'd say 8 goes into 2, not at all. And so then you can just take the other number. 8 goes into 21 2 times, and so 2 times 8 is 16. 21 minus 16 is 5. Bring down the 6. 8 goes into 56 7 times. 7 times 8 is 56. Subtract it. 0. So 216 divided by 8 is equal to 27, and that means that 8 times 27 is equal to 216. So just to review how long division works. If a polynomial is a factor of another polynomial, then that means that when you do a division, it goes in evenly. So for example, 4 is a factor of 12 because 4 times 3 is exactly equal to 12. It also means that we have identified the point where the graph intersects the x-axis, a zero, root, or a solution. So remember that when we have, say, a quadratic, there are 2 roots, or solutions, or zeros, and that's where it crosses the x-axis. And so what this division can help us do is find out where those locations occur. And that doesn't work just for quadratics, it'll work for all other polynomials, so this will be something helpful. Okay, let's take a look at example 3. We're going to consider f of x is equal to x squared plus 7x minus 18. So this is a quadratic. If x minus 2 is a factor, then that means that when x is equal to 2, then it's going to cross at that point on the x-axis. So whatever that polynomial is, it would cross, that's not a very good picture, it would cross at that point. And so that would mean that it's a factor. It doesn't mean it's the only factor, but it just means that it's a factor. If x minus 2 is a factor, we can find out by substituting and finding out if it's equal to 0, because when y equals 0, that's where it crosses the x-axis. So we can just substitute, do f of 2. So we do 2 squared, that's x squared, plus 7 times 2 minus 18. And that's going to be 4 plus 14, which is 18, minus 18, and that's equal to 0. And so because it's equal to 0, then that means that that occurs when y is equal to 0. So when x is equal to 2, y is equal to 0, and that means that that is a factor, it's a root, it's a 0. Alright, so in example 4, if g of x equals x to the third minus 3x squared minus 11x minus 2, is x plus 1 a factor? Is x plus 2 a factor? So the way that we can tell, if x plus 1 is a factor, that means that x equals negative 1 would have to work for g of negative 1. We would have to get a 0 if it is a factor. So let's plug it in. Negative 1 to the third power minus 3 times negative 1 squared minus 11 times negative 1 minus 2. Negative 1 minus 3 times 1 plus 11 minus 2. So that's negative 4 plus 11, which is 7 minus 2. It's not equal to 0, and right now it doesn't really matter what else it is. We just know it's not equal to 0, so the answer to that is no. x plus 1 is not a factor, and that just tells us that the graph of x to the third, this right here, that's not going to cross the x-axis at -1. Okay, so the next question is x plus 2 a factor? So that would mean that if it was, x equals -2 would give us 0 when we do g of -2. So let's go ahead and try that. So -2 to the third power minus 3 times -2 to the second power. I'm just substituting in here. And so when I do that, it is equal to 0, and so -2 is a 0, x plus 2 is a factor. So let's distinguish between that. Alright, we can also use long division to divide polynomials. This can help us find all the factors because sometimes, especially if you have something that's a cubic function or a higher order polynomial, there's many factors and you maybe can't just find all of them by just doing what we've done with quadratics before. So we can use long division to help us get down to something we can find. And so the way we're going to do that is we're going to find the quotient or the answer to the division problem for this quadratic divided by this linear equation. And so the way we do that is we set that up in a long division problem. So we're going to put x squared plus 15x plus 50, and we're going to divide that by x plus 5. So you just set it up as if it was just numbers that you saw in elementary school. And now what we're going to do is we're going to go through the same exact process. We're asking ourselves, what can I put right here so that this number times x is going to give me x squared? And so that hopefully is not hard for you to come up with. We're going to put x right there. So just like we did in long division, we're going to say x times x is x squared. But then we also have to say x times 5, and that's going to give me 5x. Now again, just like we did with long division with numbers, now we're going to subtract that, and I'm going to subtract everything there. So x squared minus x squared is 0, and 15x minus 5x is 10x. Now I'm going to bring down the next number, so plus 50. Okay, now what I'm going to do is I'm going to say what number can I put right here so that this number times x will give me 10x. So I will say 10, because now 10 times x gives me 10x, but then I'm going to say I have to do 10 times 5 also, so that 10 times 5 is 50. And now again I have to subtract everything, and what that does is it gives me 0, 0. I have nothing left, and so that means that x plus 10 is the quotient, so this would be my answer to the division problem. It also means that if I was to factor this polynomial, the factors would be x plus 5 and x plus 10, so x plus 5 times x plus 10 would equal my quadratic. Now because this is a quadratic, and we know it just has two solutions, I can actually find them by looking at my factors. My zeros, or my roots, would be -5 and -10, as we've learned before. So I can tell a lot from this. In the end, the answer to this question is just this x plus 10, but we will be asking a little bit about factors and zeros as well. Okay, let's try another one. So we're going to set up the division problem, x squared plus 2x plus 1. We're going to divide it by x plus 1. So here again we're asking ourselves what number should go right there so that I can have that number times x gives me x squared. And hopefully you know that that's going to be x. So x times x is x squared, and x times 1 is x, and that's positive, so now I'm going to subtract everything. It's important that you understand you're subtracting everything there. So x squared minus x squared is 0, and 2x minus x is x, and then we're going to bring down the next number, so plus 1. So then I'm going to put plus 1 because 1 times x is x, and that's what I wanted to have right there. And then 1 times 1 is 1, and then I'll subtract all of that and I get 0 left over. So my answer is equal to x plus 1. So if you think about what that means, it means that x plus 1 times x plus 1 is equal to x squared plus 2x plus 1. Think about factoring and things that you've learned before, and you should see that that is obviously true. The zeros for this, or the roots, or where the graph crosses the x-axis, would be at -1. And in this situation, there's just the 1 point, and so it would be the vertex of the quadratic. Okay, pause the video and see if you can do example number 7, and then turn it back on and see if you got the right answer. Okay, what you should have done is said 2a, that's going to give me 2a squared minus 6a. Subtract all of that, you're going to get 4a minus 12. And then you're going to have plus 4 on the top, so 4 times a, 4 times -3, and I subtract everything. And so my answer is equal to 2a plus 4. Okay, another example. Pause the video, see if you can get the right answer. Okay, this one is going to be 5x, and 5 times -2 is -10x. You want that first number to be exactly what's in that position right there. And so 5x times -2x is -10x, and 5x times 1, that's 5x. And we're going to go through and subtract everything, so that means change all the signs. So I'm going to have 8x, bring down the -4. So I'm going to have minus 4, because remember that -4 times -2 is positive 8. So that's going to give me 8x, and -4 times positive 1 is -4. Left over 0, so we're going to have a quotient of 5x minus 4. So here again, that means that -2x plus 1 is a factor, and 5x minus 4 is a factor, and when you multiply them together, you're going to get -10x squared plus 13x minus 4. It also means that 1/2 is a 0 and 4/5 is a 0, because when you solve these and find out when y equals 0, x is equal to these two numbers right here, that gives us our zeros or our solutions. So make sure you understand the difference between factors and solutions. Quotient right there. Now obviously every number is not going to go in evenly, and so every number is not going to be a factor. Every linear equation will not be a factor of every quadratic equation. And so sometimes you're going to have a remainder. Now in long division, we would see that here. So if I say 7 goes into 8 one time, 1 times 7, subtract it. 7 goes into 14 twice, 2 times 7, 14, subtract it. And I bring down that 9, and 7 goes into 9 one time, and I have 2 left over and there's nothing else to do. Now at that point you either bring in decimals, or you can say that it's 121 plus 2/7, or 121 and 2/7, or 121 remainder 2. And so one thing let me clarify is that this first way I wrote it, what that means is that 121 times 7 plus 2/7 times 7 is going to equal 849. And so you can do the math and see that that does in fact work out. And so that's what we could write as one of our options for ways to write an answer for that. So when there is a remainder and you're working with polynomials, that means that the polynomial you're dividing it by is not a factor, and it won't give a solution. So let's do an example. So you're going to have x squared minus 4x plus 10. We're going to divide that by x plus 2. So when I say, okay, x times x is x to the second, and x times 2 is 2x, go through and subtract everything. So I'm going to have -6x, bring down the 10. So minus 6 is on the top, -6 times x, and -6 times positive 2. And when I go and subtract everything, I'm going to have 22. There's nothing to bring down, and so that is my remainder. So the way that I write that is I'm going to write my quotient as x minus 6 plus 22 divided by x plus 2. So you take this number and that's going to go right there. And so that would be my quotient. Now, it doesn't look very pretty, but that's the way you can write that. X plus 2 then is not a factor. X minus 6 is not a factor because there is a remainder. So there may be other factors, but those are two that are not. Okay, so now this time we're going to have actually a cubic polynomial. So x to the third power minus 9x squared plus 14x plus 19. One thing that you want to be careful of is just in case, sometimes your polynomials are not given to you in standard form. If they're not, you need to make sure that you put them in standard form. So you want to make sure that x to the third, and then x to the second, x to the first, x to the 0. Make sure everything's in that order, because otherwise it's not going to give you the right answer. And then we're going to divide it by x minus 3. And so really this is no different. You just have an extra round to go. So we're going to have x squared times x is x to the third, and x squared times negative 3. Okay, so on this one, you're going to have a leftover of 7 right down here. And so the way that you write your answer is you would write your answer as, I'm running out of room here. You're going to write it as x squared minus 6x minus 4 plus 7 over x minus 3. And that would be your quotient. Okay, that's the end of this video, and so you can now complete your worksheet practice 1 through 15. Make sure that you are being very careful, you watch your signs, and double check your work. If you need help, come and see your teacher. And there is one more video after this.